Hey guys, so today in class we were looking at the law of sines, and we found that the law of sines is sine of angle A over side A equals sine of angle B over side B is equal to sine of angle C over side C. Now we can also write this in the reciprocal format, so sine A over sine of angle A, and then B over sine B, and C over sine C. Real quick, make sure please that whenever you're talking about an angle, you use a capital letter, and whenever you're talking about a side, you use a lowercase letter. And just in case you didn't catch it today, if this is angle A, then side A is the one that is opposite it. So if this is angle B, this is side B, opposite it, and angle C, this is side C. Okay? And the trick with law of sines, there's a bunch of different cases. For instance, this is angle, side, angle. That's the case that we're in right now. I think easier, though, than memorizing cases is to remember that with law of sines, you always need an angle and its opposite side for it to work. You basically need enough information to fill out one of these fractions completely. And so right now, I've got this angle, but I don't have the side. I have this angle, but I don't have the side. And I have this side. Okay, what that tells me is that I'm going to have to use C, and that means before I do any other work, I'm going to have to figure out what angle C is. Now that's not too tricky. I'm just going to add these two angles together and take it away from 180. So angle C equals 180 minus 75 plus 60. So we get angle C is, tap, tap, tap on my calculator, even though I probably could do that in my head, and we get it's a 45-degree angle. So this guy right here is 45 degrees. All right, now that I have that set up, now I've got an angle on its opposite side. Once I have that much information, I can use law of sines. Now let's see, I'm going to find A first because it comes first in the alphabet. And what I like to do on law of sines is whatever I'm going to find, that's the first thing I write on the paper. So I'm going to write A first. I know it's going to be over sine of big A, which is 75. And then I have to use the two pieces of information I have. So I'm going to use side C and angle C. So 340 miles over the sine of 45 degrees. Now, the reason I like to put my unknown on the top left is because it makes it really easy to isolate. Now, I could cross multiply. I saw several of you guys doing that in class today. But I don't really need to cross multiply. The only thing I need to do to get A by itself is to multiply both sides by sine of 75. Because that cancels there, sine of 75 here. And I've got A by itself. So now, at this point, I'm going to grab my calculator, and the only thing I need to really make sure of is that the mode is in degrees. See how I'm in radians right now? It's going to give me kind of a wonky answer. Now, the way you know whether to be in degrees or radians is you look at the problem. I'm taking sine of 45 degrees. That means my calculator better be in degrees. So now, let's see, I've got calculator in degrees. I'm going to do 340 times the sine of 75. I'm going to make sure to close that parenthesis and then divide that by the sine of 45. And I get about 464.4, we'll just round that up to, round down to 0.4 miles. So we get 464.4 miles. And I like to, you don't have to, but I always like to go up and label it on the actual triangle so that at the end of the problem I can compare my picture to make sure things make sense. So 464.4 miles. And then after that, if I wanted to find side B, I can do the same thing. Now, it's always a good idea to use your given information as much as you can. That way you're not carrying on rounding answers. So I am going to use side C and angle C again in this problem when I move on to B. So I would take sine of B, which is 60 degrees, is equal to 340 over the sine of 45. Multiply both sides by sine 60. And we get B is approximately, oh, you know what? I just did a calculator trick that you guys should see. Some of you maybe already know this. So I know that I'm getting pretty much the same thing here as I did above. I want 340 times the sine of something divided by sine of 45. The only thing that's changing here is the 75 and the 60. I'm lazy and I don't want to have to retype all of that into my calculator. So what I'm going to do is hit the second button, your yellow button here, and then the enter button. If I hit second and then enter, what's going to happen is it's going to pull up the entire line, all of that's typed in there. So second enter. Oops, I already hit it once, sorry, because I did it without showing you guys under the camera. So second enter, pulled up the line above, second enter again. There we go, pulls up the line I want. And now I can just move my cursor and change this 75 to 60 without having to retype everything. And I get 416.4 miles. Now the reason I like to write them on the triangles, I like to check. My biggest angle should be opposite my biggest side, and it is. My smallest angle is opposite my smallest side, and my medium angle is opposite my medium side. Always just a good idea with triangles to make sure that your triangle actually looks like it could be a real triangle. All right, for my second example, in this situation I have two sides instead of two angles, and I have this angle here. Now I do have the angle on its opposite side, so that tells me cha-ching, I get to use law of sines. And since I have this 7, the first angle that I'll be able to find is angle B, because law of sines always works in opposite pairs. So since I want to find angle B, I'm going to put sine B on top over side 7, or side B. And then that's the sine of 45 degrees over 10. And again here, I could cross multiply, but I don't have to. I can just multiply both sides by 7, and I get the sine of B equals 7 times the sine of 45 degrees over 10, which I can use my calculator to turn into a decimal. So 7 sine of 45 divided by 10, making sure that I close that second parenthesis before I hit enter. Okay. And here I'm getting 0.4949, so let's say that's sine of B is approximately 0.495. I'll go out to 3 decimal places. Okay. And now to get B by itself, I have to cancel sine out. Well, you know how the opposite of squaring something is square rooting? Those are inverse operations. They would cancel each other out. Or like the opposite of multiplying by 3x is to divide by 3x. Those cancel each other out. Well, the opposite of a sine is a sine inverse. They're inverse functions. And so if I take the sine inverse of both sides, this sine inverse cancels out this sine the same way that a square cancels out a square root. And I would get B by itself. And then this sine inverse is actually on your calculator. It's right above the sine key. So you're going to hit second and then the sine key. And I'm going to use second sine, so I get sine inverse. And then I'm going to hit second and then ANS, which is this negative sign here. So second ANS, to put that whole decimal, not the rounded decimal, in, and hit enter. And I get about 29.66, so I'm going to say 29.7 degrees. Okay. So sine inverse is how you're going to find angles if you hit a problem that you need to do that. Alright, that's it for notes, guys. Make sure you check the blog and do the couple of homework problems that are assigned there, and I will see you guys in class tomorrow. Thanks!